In this lecture, I am going to consider the collaborative filtering, basic introduction of collaborative filtering, search or content-based method, user-based collaborative filtering, item-to-item collaborative filtering, and using Google's PageRank and memory-based algorithms. So first discuss the recommendation system, the system that evaluates the quality based on the preferences of others with a similar point of view. It's called recommendation system. For example, the there are this in this table there are some movies like Star Wars, Hope Dream, Contract, Titanic, and there are four others users. Then what will be the recommendation value? There are different user reviews ratings to different movies. So what will be the recommendation rating for Nathan for this movie? Such instances can be calculated by using a recommendation system. Actually, collaborative filtering, the problem of collaborative filtering is to predict how well a user will like an item that he has not rated given a set of historical preference judgment for a community of users, such for example the case here. It predicts the opinion the user will have on the different items. It recommends the best items based on the user's previous likings and opinions of like-minded users whose ratings are similar. So collaborative filtering in our life, for example, in search engine like data mining, when we search data mining, we get several sponsored links related to that particular keyword, and for example some other features like knowledge discovery, etc. When we purchase some book on Amazon, for example data mining, then it also shows the information like customers who bought this item also bought some other books like data mining with their ratings. So these are the examples of recommendation system or collaborative filtering, examples of collaborative filtering in our life. Some methods like search or content based method for collaborative filtering. Given a user's purchase and rated items, it constructs a search query to find other popular items. For example, for search query like data mining, this system identified other similar items. For example, some author, artist, director, or similar keywords or subjects. It is impractical to base a query on all the items. So we require some more refined algorithms for this. Now the next part is user-based collaborative filtering. This is highly expensive and not very useful because not same is different users may have different likes and dislikes, and there may be variable or dynamic due to different number of users, variable number of users, or their dynamically changing behavior. It is very tough to predict the ranking of any items based on the user behavior. Here also it is marked like complexity grows linearly with the number of customers and items. The sparsity of recommendation on the dataset. Even an active customer may have purchased well under 1% of the products. So it is not practical to use the user-based collaborative filtering. item to item collaborative filtering. Rather than matching user to similar customers, build the similar item table by finding that customer tend to purchase together. For example, in previous example, like the person who bought the book on data mining also purchased the book named as The Elements of Statistical Learning by T. Hestey. So this is an example. Amazon.com uses this method. It scales independently of the catalog size or total number of customers, because here the number of items are fixed but number of users are not fixed. It is acceptable performance by creating the expensive similar item table offline. Item to item collaborative filtering algorithm. For each item in the product catalog I1. Now the next loop inside. For each customer C who purchased item I1. For each item I2 purchased by customer C, record that customer purchased I1 and I2. For each item I2, compute the similarity between I1 and R2. First thing is, for each item in the product catalog, suppose I1. Now for each customer C, who purchased I1, and for each item I2 purchased by the customer C. Here the similarity between items calculated like this. Suppose this is item 1 and this is item 2, and these are the customer C1, C2, C3, C4. Suppose then it prepares the similarity like that. Now two customers purchased item I1 and also purchased item I2. Then similarity score will be around 50%. I think it is based on such kind of a score, they predict the similarity between item I1 and I2. The time complexity is big O of n square m, and in worst case ONM in practical. As a worst case, and ONM is practical, where n is the number of items and m is the number of transactions in the matrix. So this is simple item to item collaborative filtering similarity calculation, computed by looking into item correlated item only. Here also these correlated pairs are obtained from different users. Here user is different, item is different. Sorry, here n is number of items and m is equal to number of users, number of rows in matrix. For the similarity between two items I1 and I2 calculated by user rating of item I1 by user U by mean of all user rating of U into, where U represents number of all users, similarly into user rating of item j minus mean of user ratings divided by this score. Here sum of u number of users, sum user rating of item I by user u, mean of user rating whole square, and then summation of all such whole squares. And similarly here this division represents the similarity between item I1 and I2. It looks very similar to the cosine similarity. The item to item collaborative filtering algorithm, prediction and computation. Now it uses the weighted sum. The prediction is based on the weighted sum, 5 closest neighbor of each product. For example, for any given product, these are the total 5 closest neighbor of any given product. Then recommend items with high ranking based on similarity that we calculated here. Here we can calculate the prediction by we predict the item based on the weighted sum of similarity and regression based features. Weighted sum to capture how active user rates the similar item can be calculated as all similar items, sum where all similar items, and n such that similar items n into user ranking of item n by user u divided by similar items into number of items and their summations. In this equation, the regression is used to avoid the misleading in the sense that two similarity may be distinct yet may have very high similarity. Means both items are not the same items, both are different varieties of items, but still are similar. It can be calculated by using this simple expression. Google's PageRank can be also used in calculation of collaborative filtering or ranking of an item. The main feature is in-links are good recommendations. In-links from a good site are better than in-links from a bad site, but in-links from site with many outlinks are not as good. So good and bad are relative. For example, here imagine a page hopper that always either follows a random link or jump to a random page. Imagine a page hopper. Now PageRank ranks the pages by the amount of time the page hopper spends on the page, or if there were many page hoppers, PageRank is expected crowd size. So here PageRank will be the highest. This type of situation can be used to rank the items for collaborative filtering. The classification of collaborative filtering algorithm. A popular classification of collaborative filtering algorithm was proposed by Breese et al. Into memory-based and model-based methods. Memory-based method work on a principle of aggregating the labeled data and attempt to match recommenders to those seeking recommendations. Most common memory-based method works are based on the notions of nearest neighbor using variety of distance matrices. It may use the entire database of user rating to make predictions, find users with similar voting histories to achieve the active users, or use these users vote to predict rating for the product not voted by the active user. So these are the goals and features used by the memory based method. Next is the model based methods. On the other hand, try to learn a compact model from the training data. For example, learn parameters of a parametric posterior distribution. From an operational point of view, memory-based method potentially work with entire training set and scale linearly with the amount of training data, while model-based methods are constant time. It constructs a model from vote database, use model to predict the active users rating. For example, use of singular value decomposition or type of things can be used here. So memory based algorithm, mean square differences, Pearson correlation, vector similarity. Model based algorithm use Bayesian networks, neural networks based model or Boltzmann mechanics. Or other hybrid algorithm, memory and model based approach, singular value decomposition, probabilistic latent semantic analysis, etc. First, K nearest neighbor based model. The technique uses individual user distribution to measure the distance between user and then make the prediction RUI and MG based on the rating given MJ item MJ by user UI. Rating of item MJ given by user UI. The intuition here is that if many users rate two movies the same, the movies should be considered similar. Conversely, if many users rate two movies differently, the movies should be considered different. Calculate the similarity between each user by comparing how each user has rated common content. If Frank has rated something 4 by 5 stars and Jane has also rated it 4 by 5 stars, then these users would be considered similar. Again, these calculations are very time consuming and as it essentially becomes the handshake problem. That is, the calculation has to be performed for each unique combinations of users. The number of unique combinations may be n into n minus 1 by 2. This is a simple nearest neighbor classifiers algorithm that I already discussed earlier. So I will just go through the example. Step 1, content based survey classification. Suppose x1 represents the user's rating, x2 represents the movie's mean rating, and y represents the classification. User's rating 7, movie's mean rating is also 7, likely to be seen by an action fan. Similarly, both are different, but difference is not very less, and still score are very high. Score are high, so likely to be seen by an action fan. But here scores are low, so not likely to be seen by an action fan. Here also the same. So we get two classification. Now the new user rates movie for x1 is equal to 3 and x2 is equal to 7. Without another expensive survey, can we guess that classification of this new movie is? Determine parameter k, number of nearest neighbors. Suppose we use k is equal to 3. Then How to calculate the distance between query instance and all the training samples. Coordinate the query instance is 3 and 7. Instead of calculating the distance, we compute the square distance, which is faster to calculate without square root. So this is user rating, this is movie mean rating, and this is the classification score here. Now the step 3, sort the distance and determine the nearest neighbor based on the kth minimum distance. So x1 users rating, x2 movies mean rating, square distance from 3 to 3 and 7. So rank the minimum distances. Is it included in 3 nearest neighbor? Yes, yes, yes. Now gather the category of the nearest neighbors. Notice that the second row, last column category of the nearest neighbor not included because the rank of data is more than 3. So what will be the category? Category likely to be seen by an action fan, not likely to be seen by, not likely to be seen by action fan. 3 nearest neighbors. Step 5. Use the simple majority of category of users nearest neighbors as the prediction value of the query instance. We have 2 not likely to be seen by an action fan and 1 likely to be seen by an action fan. Since 2 is greater than, so we conclude that new movie with x3 is equal to 3 and is included in the former category. So this is the simple example of categorization by using k nearest neighbor. Now the memory-based algorithms by user voting. Suppose Bij represents the vote of user I on item j. II represents the item for which user I has voted. Then mean vote will be calculated by using this scheme. Vi is equal to 1 divided by mod of II, or sum of where j member of item I, then Vi into Vi ji means vote of user I on item j. Calculate the sum of all such kind of vote divided by sum of item count. Now we can predict the vote for active user A as a weighted sum of here. This is the normalization factor and represents the weight of all similar users. Vi is equal to mean of all user votings. K nearest neighbors already explained. Now after that, Pearson correlation coefficients can be used, where Vaj represents the voting of user A on for item j, mean of all voting by user A. Similarly, voting of user I for item j, mean of all votings divided by this score. Similarly, we can calculate the cosine distance also. We already discussed how to calculate the cosine similarity or cosine distance. Thanks.